Hello, my name is Touma. My ID is 6359553, and this is the lab video report from for lab 5 from group 2.
Hello, good evening. My name is Mohammed Alsabbaghe. My ID number is 5731743. This is a submission for lab number 5, I mean.
Hello, I am Hannah Contramaestre. This is for class EEL 3110C, part of group 2. This is lab number 5. I'm doing activity 2, and I'm doing with Mohammed. I'm doing the other 2 parts.
Here in activity 1, I created that same circuit with the conditions stated below, and I made Vm be equal to 1 volt to meet the condition. And the objective of this activity is to determine why the change in radians times seconds or hertz affects the value of volume and also the graphs of the circuit. To meet all the conditions, I also had to change the values of W in the 3 cases to their equivalent in hertz by dividing the value by 6.28, as you can see, so that the value of hertz could be measured with the circuit and shown in the diagrams. In this first case, the output signal is equal to the input signal, as you can see on the values of the volts. This is because the value of W, or in this case the hertz that I inputted, were so small that the change was extremely minimum, so it didn't affect the volume at the end. That's why the graph looks like a straight line. In the second case, everything is the same except, once again, the value of hertz, which in this case is a little bit bigger, which make a difference in the volume because it changes from the beginning to the end, becoming bigger, and also changing the VDC in both cases. That is why the graph looks a little bit more curved than the first one. Here in the last case, the difference in VDC in the input and output is very large. Here, once again, it's all the same except the hertz that were changed and now are way bigger than the previous one. And as you can see in the graph has a lot of more waves compared to the previous one because it has a way bigger difference. This means that the output is considered distorted sinusoidal, which means that at higher frequencies, the DF amp behaves non-ideally. In conclusion, the higher the hertz or the radians divided by seconds are in this type of circuits, or basically in the input, changes the output and also affects the graph of voltage over time, as you can see, where the bigger it is, the more wavy it becomes, which means that there are more changes per second.
Hello, this is a submission for lab number 5. I was responsible for doing the graphs on the multism. This is what I did here. This is for when R1 is equal to R2. The only difference is for the other one is you change this value to 2. This is what you did. This is what the graph looked like. This is for the second part. Change it to 2 when R1 is less than 2.
Okay, so I had to put it on WhatsApp, the pictures, because it wasn't showing up well through email, and I could not. Yeah, anyways. Also sorry if the pen marking looks a little bit sketchy. It's because my pen on my tablet ran out of battery and I had to do it by hand and it just looks bad, but I thought it would make things clearer. So basically on this one, you set up the whole entire circuit, which I'm sure Mohammed's going to talk about. And what I'm talking about is the second 2 parts, which is the R1 is less than R2. And in this one, you can see that basically the gain is 3000 by taking the 2.99 voltage, which I highlighted over here. And basically, I'm just matching it to the checkpoint at the top of the graph to the other one. And yeah, that's when R1 is less than R2. And then, ooh, can I switch? Hello. Okay, and then for when R2 is equal to 100 ohms and oh wait, did I say R2? I think I said R1. R1 is equal to 100 ohms and R2 is equal to 1 m ohms. I think that's what I wasn't sure because in activity 2 it only said m ohms, so we just put 1. So basically, I just marked up with the check marks at the graphs to show it better. And basically, we can see that from the graph that the op amp is saturated. And yeah, these are the last 2 parts of the activity number 2. And Mohammed will talk about R1 when R1 is equal to R2 and when R1 is greater than R2. Thank you.